Hello, Chemistry 3. As you can see here, we're going to be talking about some of the different states of matter, looking at gas, liquids, and solids, and then also getting into the fact of different compounds, mixtures, pure substances versus mixtures. Okay, so why don't we go ahead and get into this? Looking at our first slide, we're going to take a look at basically go ahead and define what matter is. Matter is defined as anything that takes up space. Okay, it has to have mass. So if you think about, we've been doing density, we've done density labs, we've done density problems. So we're talking about anything that has that mass to it. When you put it on a balance, it means it has matter, or it is matter. Okay, so anything that takes up any space. Matter is found in basically in 4 different states. Okay, there's solids, liquids, gas, and plasma. We're going to run through solids, liquids, and gases. Plasma is one that's not typically always talked about, but it's another state that matter is found in. But let's go ahead and take a look at solids, liquid, and gases from here, and this is going to give you a little bit of an image. Looking at the particle or the atom form, okay, you can see here the solids, liquids, okay, your particles are a little bit more free to move. Your gases have a little bit more space between them, and then you can see where your plasmids fall in. And as you add heat to them, okay, these atoms get spread out a little bit more. They're more active, and then more collisions occurring and also going by each other. Okay. All right. So first one is solids. Looking at solids, the characteristic about solid here is that it has a definite volume and a definite shape. Okay. And there's very little movement with these particles, and you can see that up in here in this little picture or image that the shape of the container, okay, it's a solid. It's not going to change. And these atoms that are found within them, the particles that are found within them, there's no room for movement. Now, they're always moving slightly, but they're never going to be able to slip by each other. They're never going to flow, and so they're really tightly compact together. Okay, so solids, definite volume and shape, and these particles are very close together, so there's limited on its type of movement that occurs. The second one state here is liquids. Okay, and again here we have a definite volume with a liquid because if we have a 2-liter can or a 2-liter bottle of pop, and we put that 2-liter pop in another container, okay, we still only have 2 liters of it. We didn't change. We can't change how much we have of it. Okay, when we're talking about the volume. Now the shape of that 2-liter pop, when you think about the liquid, it takes on the shape of the container that you actually place it in. Okay, so it has a definite volume but no definite shape, and because of the chemical properties here of the liquids, there's this fluidity to it. It's able to move because these particles are able to slip by each other because there's a little extra space between them. And you can kind of see that here. There's room between here, and then also in this image, you can see there's room between the particles, so they're able to flow past each other. And they're always colliding still, but they're also able to flow by, and that's why liquids are fluid versus the solids that have that definite shape and definite volume. All right, and the last one here are your gases. And your gas, they have neither, okay, definite volume or definite shape. Okay, so the volume can change, the shape can change. Basically, what you're looking at is what the container that's placed in. You can see up here the movement of the particles. All right, they're moving. They flow pretty quickly, pretty randomly. They're able to go by each other very easily. You can see that also in this image. Okay, you can see the particles are in random motion, and the particles are always flowing. And if you think about the volume, think about maybe if you're in a room watching this, a bedroom or in a classroom, you can kind of think of it this way. If you take all the gas molecules within that room and you can compact those into a smaller volume, okay, the only thing is that you're going to be building up the pressure by making the volume a lot smaller. Okay, but you can change the volume and you can change the shape of that gas. And it just depends on the container and the size of the container that you're putting it into. Okay. All right. So we looked at the different states of matter. Now we're going to look at a couple of the 2 different properties of matter. There's physical properties versus chemical properties, and we're going to go through each one, give some characteristics about them, and how can you tell one from the other. All right. So the first one here is the physical properties, and this is just kind of giving you a pictorial of what's going on here. Here's your properties, composition, meaning the chemical properties of it. Okay, so we're actually meaning what it's made up of, and here basically we're looking at more of your what you see with your senses. How about that? put it that way. Okay. All right, so your physical properties can be observed. So this is kind of like your qualitative data. You physically can see it, right? Specific to a certain substance. So whatever substance you're actually looking at, okay, or using, it has a specific physical property to it. Some examples could be like melting point, boiling point, density. These all signify some of the pure substances that are out there, and these are all physical properties of substances, okay, that could be found, because when you think about a certain substance, its boiling point is its boiling point. You're not going to change it. If you do change the boiling point, then that means you're changing the substance, so it's no longer a pure substance. Okay. Then we have chemical properties. Okay, determines how it will react with other substances. So the property of that particular chemical is going to determine how it reacts with other chemicals. And if you went into the chemistry storeroom and you looked in the back storeroom, the chemicals are all placed in a certain order, so we do not get a mixing of chemicals that will react with each other. And some are placed further away than others. Some are placed in special containers because they're flammable or they're too strong of an acid. It just depends on what type of substance it is. Again, those properties are specific to that substance. You look at a different property, it's going to change the chemical property, and it will change the reaction it's going to have. Okay, and then this is just an example of what we're talking about. Basically, these are the chemical reactions that are going to be occurring.
Matter, the stuff that everything's made of, is made up of many tiny particles. The behavior of these particles is what makes a substance a solid, a liquid, or a gas. In a solid, the particles are packed closely together in a rigid structure, vibrating about fixed points, but unable to move around. In a liquid, the particles can move around each other, so the liquid has no fixed shape, but they're still very close together. But in a gas, the particles are spread far apart, moving around rapidly and randomly to fill the entire space.
Everything around us can exist in the three states of matter: solid, liquid, and gas.
Okay, so what we're looking at here is the physical change, okay? And with physical change, we're talking about any changes that don't change the composition of the substance, okay? It's still the same stuff. And some of the examples that you can see, and maybe you've already seen a demo, or you might be seeing some demos in class, where we have a tearing paper. Okay, when you tear paper, you're not changing, okay, chemically you're not changing it. You're changing maybe what it physically looks like, but you can't change the chemical makeup, the atoms with it. You're not rearranging the atoms. Dissolving salts and then evaporating it. Okay, you can evaporate off the water and you still have the salt there. It's not changed physically. Sorry, it's not changed chemically. You could reverse the color, or through filtration you're able to get back to the original substance that you had. Okay. So just giving you some examples, like the ice melting. Okay, water is still water. Here you can see the same idea. You're not changing the physical property, you're not changing the chemical properties of it. You're changing physically what it actually looks like. Okay, like crumbling cookies. Okay, if you had a whole cookie and then you crumble them into smaller cookies, that's just a physical change. There's still a cookie. Okay, you haven't changed it. It's still a cookie. All right. So now looking at chemical change. Okay, and these are any changes that alter the composition of the substance. So what we're talking about here is rearranging some of the atoms around, okay, and we're creating some new substance. So we started off with certain products and we ended with certain what we call reactants, and there's been some chemical changing that's occurred, basically rearranging or reordering the atoms so we come up with some new substances, okay? And anything that involves a chemical reaction is considered to be a chemical change. And some signs of chemical reactions would be, or some things you would look for would be like burning, solid formation, gas evolution, heat evolution, permanent color change. Okay, we're talking about, you get endo or exothermic reactions, you get heat given off. Okay, you're going to see flames, maybe you can see sparks. Okay, you see a precipitate forming. Those are all signs of some chemical change that's occurring, and the substance is no longer what it was originally. The atoms have been rearranged into a new type of substance. Okay, so you can kind of see here, these are again just some signs. You have flames, lightning, you have this color change occurring, this chemical reaction, permanent change, and rusting, and You can see here smoke giving off. You can see the gas bubbling within here. Okay, there's probably an odor, I would imagine, given off. Okay, so these are all signs of chemical changes that are occurring and rearranging those atoms. All right. Now we've talked about we've talked about different states of matter, and now we've talked about, now let's kind of look at how they're connected. Okay, so we have our gases, liquids, and our solids, and when we go from gas to a liquid, okay, this is what we refer to as condensation. And if you think about it, in the wintertime, you get the condensation that might occur in your windows, condensation on a glass when you're drinking some type of drink with the ice in it and stuff. And what you're doing is you're going from gas to a liquid. Now, if you go in the opposite direction, from a liquid to gas, that's what we refer to as evaporation. Okay, you're going from a liquid to the gaseous state. Like when you boil water, the steam's coming off. You get, think about your pool in the summer. You can see the levels of the pool going down, or maybe your aquarium at home. Okay, those are all evaporation that's occurring. Now, going from a gas to a solid and actually skipping the liquid state is called sublimation. Okay, so what we're doing is we're skipping the liquid state. And the perfect example of this would be dry ice. Okay, you have a solid. Okay, and where we're going, so we're going from a solid to a gas here. I think I might have stated the other way. Let me go back here. So what we're doing here again is we go from a solid to a gas is called sublimation. Okay. And then going from a gas to a solid, it's called deposition. All right. So sublimation is more the term that you need to know, is going from that solid state to the gas state. And then going from looking at between solids and liquids. Okay. You're going from solid to liquid is what we refer to as melting, and then going from a liquid to a solid is that solidification, or you might be like a freezing, something like that occurs. Okay. Now let's look at this graphically. Okay. So you can see here on the x-axis we have heat, and on the y-axis we have the temperature. Okay, and you can see temperatures going up. So obviously if we increase heat, temperature's going up. And you can see here we're going from the solid into the liquid state up to the gas state. And what you want to notice here is there's some plateaus that do occur. Okay, so what we do is we get a little heat going, we have some temperature increase, so it was a solid, and right now we've reached this plateau. It's kind of in the limbo state between the solid and the liquid. And as that solid starts to melt, okay, we hit the liquid state eventually, and then you can see there has to be a big increase in heat, okay, which increases our temperature, and eventually, eventually what we do is we get to the point again where it plateaus off. And it's liquid gas, and then what we can get is as we add more heat, so notice the temperature's not really increasing, but we are adding more heat to it, and eventually that liquid can become gas. As if you think about when boiling water. Okay. Now again, this process can be reversed, going the opposite direction, going from the gas down to the liquid. Condensation occurs, and then from the liquid to the solid through the process of freezing. Okay. So that could also occur in that particular way. All right. So this screencast, again, screencast session number 2, unit 2, number 1, was dealing with matter, some of its properties, and some of the physical and chemical changes that occur, and kind of how they're all connected. Okay, so this is Mr. Parker, Chemistry 300, and I hope this helped you out.